Okay, for 9.3, we are going to be solving quadratic equations today. So we know that a quadratic equation is set up ax squared plus bx plus c, and if it is set equal to 0, you can actually solve it just like you would an equation. Anytime it's written like this, that is called standard form of a quadratic equation. But what I want you to know is when we solve these, you're going to come up with some answers, and those answers end up being the x coordinates. Sorry, that's not what I meant to say. The x-intercepts. It's where it intercepts the x-axis. So our answers would be wherever that dot is and wherever that dot is. So for example, if I were to solve, this doesn't have an equation. Here's one. X squared minus 4. If I were to graph x squared minus 4 and solve it, let me just do this off to the side to show you what I mean. If I were solving an equation, you guys would add 4 to both sides, and you would say that x squared equals 4. Then you have to actually keep going one step further and say, well, what is x? If it's squared is 4, then I can do the opposite, which is square root each side, and you can say that x would be equal to 2. Now think about it. Could x be negative 2? Is negative 2 times negative 2 also positive 4? It is. So the answer actually has two answers. It could be 2 or it could also be negative 2. And a fancy way in math that we write this is a positive and negative together. Now, I know that that looks weird. I know you're like, wait a minute, what in the world is that? That is just the same thing as saying 2 and it could be negative 2. But people save room writing all of that out and just put a plus and a minus symbol squished together like that. And that means positive 2 and negative 2. And let's double check that. Negative 2, there's a dot. Positive 2, there's a dot. So on our parabola, where it crosses the x-axis is these two, I'm going to go ahead and call them roots or solutions to this quadratic equation. So in fact, here's where they call it roots. They call it solutions, and they also call it the zeros sometimes, and that's because to start out it's set equal to 0. So you'll hear me refer to these as the roots or as the solutions or as the x-intercepts or as the zeros. I mean, they all are just referring to that if you were to take this equation and actually solve it like you would solve an equation, the answers would be where the parabola goes through the x-axis. So that is how to do those. Let me show you 3 examples. Sometimes there are 2 answers because the x-axis could go through when the vertex is lower, and so it would go through there and there, which leaves it with 2 solutions. Now look at B. Sometimes the vertex is on the x-axis. It touches it, which means in this case there would only be one exact solution. And then sometimes it's above the x-axis like this one is way up here, and if it is moved way up here, then guess what? There would be no solutions. It never touches the x-axis. So if we tried to calculate this mathematically, in fact, I'll go ahead and prove it to you. X squared plus 1 equals 0. If we were to solve it, you would minus 1, and then you would have x squared equals negative 1. You can never have any number squared that would be equal to a negative, okay? Because a number times itself is always going to be positive. Any number, a negative times a negative is a positive, and a positive times a positive is a positive. So if you get it down to where you have a squared on one side equal to a negative, you can stop right there. You know that there's no solution. And what that means is, it doesn't mean there isn't a parabola. There is still a parabola. It just never touches the x-axis. It never has a solution that would be an x-axis solution. So that means it's either shifted way up here going up, or it's shifted way down here and it's going down. So that would be a no solution. Okay, if you have x squared equals 0, well, what's the only thing x can be? This equation is basically already solved. If you drew your line, a number squared equals 0, the only thing that you can square that would be equal to 0 is 0. So there is a solution, but it is 0. That's why there's one solution and it's on the 0. And then, like I said, this one earlier, I can go ahead and work this out if you just want to see it, just so you can make sure you're understanding it. If we were to add 1 on both sides, that would be x squared equals 1. What is x squared? 1 times 1 is 1. So the only thing x could be are positive 1 or negative 1, because negative 1 times negative 1 is also positive 1. So this should hit at both positive and negative 1. Yes and yes. Okay, so let's try a few of these. Especially if you're good at your square roots, this may come a little quicker to you. You may understand how to do this faster, but that's okay because we can always work all of these out. So we would add 16 to both sides. X squared equals 16. I hope you guys know what the square root of 16 is. If you would square root both sides, what number times itself is 16? 4. What about negative 4 times negative 4? Negative times negative is also positive 16. So it could be plus or minus 4. So if you were graphing this on the parabola, and I know you're not, but if you were, it would be 1, 2, 3, 4. It would go through there, 1, 2, 3, 4, and it would go through over here. And I know we don't know anything else about the parabola, and that's okay. We're not talking about that today. We're just finding where it would cross the x-axis. So your a term is positive, so it would be something like this because it's opening up. We know it's not going to open down because your a term is not negative. Okay, let's solve this one. First thing you would want to do is subtract 6 on both sides. You have 3x squared equals negative 6. Keep going, divide both sides by 3. X squared equals negative 6 divided by 3 is negative 2. Stop. You cannot have an x squared equal to a negative number because any number times itself will always be positive. So as soon as you get it down to where x squared equals a negative something, it's not possible. So this one will have no solutions. And again, that does not mean there's not a parabola. It just means the parabola is way above or way below the x-axis. There's no solutions on the x-axis. Okay, let's try C. So we want to add 25 to both sides. X squared equals negative 25 plus positive 25 is 0. What number squared is 0? 0, and that's the only one. So this would be an example of where the vertex is on the 0. So there's only one solution, and it is 0. All right, let's look at the next page. Ignore my notes down there. All right. This is another example where they added 75 to both sides, then they divided by 3, and plus or minus 5 was the answer. I mean, we've been doing this. It's just that these are more specific square roots, but you just keep solving it the same way. So let's just move down to the u-tries. I think it's saying you could just look at this and tell right away, because if you know the square root of 36, but I still would go ahead and practice solving it, just because, remember, if you end up with a negative over here, you can stop. So we would add 36 to both sides. M squared equals positive 36, so that means there is an answer. What is the square root of 36? What number times itself is 36? That would be both positive and negative 6. Okay, and I know I'm not asking you to do this, but it would be on the parabola there and there. And it's a positive, so it would be opening up. Oof, that would be a really weird parabola. Sorry for my terrible sketch. All right, let's try B. First thing you would do is subtract 15 from both sides. You've got your 3x squared equals negative 15. It's okay for now. We just need to keep going and make sure it doesn't stay like that. Divide both sides by 3, because sometimes you divide by a negative and that takes it back to positive. But in this case, I'm sorry to tell you, it did not. So you can't have an x squared equal to a negative. Cannot. So this is going to be a no solution. There will not be any roots or any zeros on your actual x-axis. There will be a parabola, it just won't touch the x-axis. All right, last one of these. Let's minus 16 from both sides. 4d squared equals 0. Divide both sides by 4. D squared equals 0, which means that there's only one solution, and that one solution is 0. All right. This is our lesson review over everything today. It was a short lesson, but it's good equations practice. So go ahead and push pause and try these 4. If you're not quite ready to push pause and try them on your own, I will work them out with you. Number 1, I'm going to have to work them out over here so I have more room. So I would add 25 to both sides. X squared equals 25. The square root of 25 is 5, but it could be positive or negative 5. So be sure you have both positive and negative 5. Number 2 is 2x squared minus 8. So we're going to add 8. Bring down your 2x squared equals 8. Divide both sides by 2. X squared equals 4. So what is the square root of 4? That would be 2 and negative 2, because negative 2 times negative 2 is also positive 4. All right, let me try number 3. It is, if you can't see it on your own paper, t squared equals 144. So it's already done. You don't have to do any math. What is the square root of 144? That would mean t is equal to 12 or negative 12. Okay, and then the last one, y squared minus 225 equals 0. Let's add that 225 to the other side. Y squared equals 225. I don't really know what that is. I'm going to use my calculator. So I don't know if you guys know where the calculator button is for square root. On my calculator, it's this yellow one up here. It's kind of above the button x squared. So I have to push this shift button, the second button, and then the x squared button so that it will access this little part above it. So now it looks like square root button, 225 equals 15. So I didn't know that. So the square root is 15, so it could be positive or negative 15.